All right, so we're at our final experiment with this sand, and this is probably a little difficult for you guys to do at home if you're by yourself, but I think you can still do it. And the idea here is that we are going to move this into a saturated state. As Lucy mentioned before, it's not in a saturated state, it's not behaving saturated because it's drained so quickly. So what I'm going to try and do is pour this in and have Lucy shake it to create an earthquake to see how much relative energy is required to fail the slope in a saturated state. So Lucy, if you would start to shake as, go ahead. Go ahead. Okay. So it's a little difficult to show this experiment on this scale because we have water that's able to flow out rather than to flow into other void spaces. But what should be obvious, I hope, is that in a saturated condition, this soil fails out immediately with very little resistance to earthquake energy. So if we look at our chart now, we can say that the dry, if you remember your original energy, I would say that it's a lot less required to fail it in the saturated condition. So we'll put a -2 here. And we didn't do a hypothesis for the dry and saturated angle of repose, but this actually looks very good, and I think it really expresses what I was hoping for you guys to understand. That in a dry state, we have a medium strength with a medium angle of repose. In a moist state, we have a very high strength with a very high angle of repose due to the force of water holding itself together through surface tension. And in a saturated situation, we have a very low strength with a low angle of repose because water touching itself has no shear strength. We're going to see another example of that when we move on to earthquakes and we look at liquefaction. So that's it for this video, and I'm going to ask if there's any questions. We're going to come back and do one more question and answer session.